class? Last class, what did we discuss? Just refresh the things now. Yesterday's class, what did we discuss?
Resistance, pure resistance.
Ma'am,
We
RMS
were
value, average
discussing,
value, peak factor.
we were discussing how to convert star to delta. Yes, we were discussing how to convert star to delta and delta to star transformation we have discussed in the first unit, and from second unit we have discussed how AC can be given to different circuits, and in what all ways you can represent an AC source as RMS, average and maximum value, and how to derive the formula for all these things, and the basis of which how to derive the formula for form factor and peak factor. We have derived all these things for three types of waveforms. What are the waveforms that we have discussed? What are the various waveforms for which we have derived
Ma'am, sinusoidal,
Sinusoidal,
sinusoidal and non-sinusoidal.
rectangular,
Half wave,
sawtooth.
half, half wave, full wave, sawtooth we did not derive. Okay,
Half
it's
wave
in the
and full wave.
PPT. Yes, half wave, full wave, and full sinusoidal wave we have seen. And I have given an introduction for a derivation part when AC source is being given to a purely resistive circuit plus different types of power. We have discussed what are the three different types of power
active power, reactive power, apparent power.
and what are the formula and the units for all these powers.
Active power P equal to VI cos phi.
VI cos phi.
Reactive power Q equal to VI sin phi. Apparent power S equal to VI.
Ma'am, yesterday's
What are
unit
the
2 will be not there
units?
for CT1.
Unit representation for all the three types of power.
Active power watts, reactive power volt ampere, reactive apparent power
I
volt
don't
ampere.
know. Maybe if it is November 11, it all depends on the
Ma'am, your voice is buffering, ma'am.
subject coordinator.
Ma'am, your
Okay,
voice
but
is
start
break.
to delta is there.
Ma'am,
Okay,
your
ma'am.
voice is
Ma'am, and
breaking.
will you please share yesterday class video?
Okay, if all are finishing some topics in second unit, maybe second unit portions may also be included. Okay, these are the units. What is power factor? One final thing. What is power factor?
Cos phi.
Is the
Okay, now
The ratio between
is
what
the
is power
ratio
real
factor?
power to apparent power.
Cosine of the angle between V and I. Okay, so there are so many ways in which you can represent power factor. So all these things you have discussed in yesterday's class. Today's class again we will see to what will happen if you are giving an AC source to a purely resistive circuit, purely inductive circuit, pure capacitive circuit. RL, RC and RLC we will discuss. Okay, so the given circuit has what all components here in this slide?
current, resistance, voltage.
Current, resistance, voltage. Voltage source is there, which is given by the formula E is equal to Em sin omega t, that is being applied across a purely resistive circuit. This is a pure R circuit and we are assuming the current to be I. Okay, and we are giving a sinusoidal single phase AC only, so that's why the input voltage is being represented by the usual representation, that is V is equal to Vm sin omega t. Okay, only the notation is they are changing. Instead of V, they are using E here. Both are one and the same only. Now I want to derive the formula for I based upon Ohm's law. I is equal to voltage divided by R. So you know what is E, so that you can substitute in this equation. Okay, so I will be equivalent to what now? I will be equivalent to Em sin omega t divided by R. Now this factor I am considering to be Im. So the formula will become Im sin omega t. That is how this formula comes for I. and this is the formula for V, and I want to draw the phasor diagram between the voltage and the current parameter. So if I draw the phasor diagram, what will happen? Both are in phase parameters or out of phase parameters?
In phase.
In phase.
In
In
phase.
phase. So if I am drawing the phasor diagram, V as reference is taken here, or here we'll use the notation E, and I is also in phase. Both these quantities are in phase, okay, and if you see to the phase angle difference between these two quantities, phase angle is 0. Alright, that is why phase angle is 0, and so the cosine of the phase angle, if you take cosine of the phase angle, is equal to power factor, that will be equivalent to what value? Cos 0. So what is cos 0?
1.
0 is 1.
Cos 0 will be equivalent to 1. So always when it comes to a purely resistive circuit, okay, this is a pure resistive circuit for which the power factor is unity always. Okay, and V and I are always in phase. Okay, so this were the things that we have discussed earlier class. Now we'll move on to what will happen if you are using a pure inductive circuit. Instead of resistance, if you are going for a pure inductive circuit with the same setup, what will happen? Okay, now this circuit shows what elements? There is a circuit shown. What are the various elements that are present there?
AC source, current, and inductor.
Okay, so there is an AC source again which is being represented by what formula? EM sin omega t, and it is connected across an inductive component, and again you are assuming I, which you are going to derive, and for that you are going to use the voltage current relationship for an inductance. The voltage current relationship is VL is equal to L into di by dt. That relationship only you are going to use. So let's derive I for that. Okay, so I is equal to L into, sorry, what is the formula that relates current and voltage for an inductive element? L into di by dt is equal to what?
V.
E, no? Oh, E. E or V. Okay, so I want I, so E divided by L into integral of I dt. So I is equal to E divided by L. I know the formula for, sorry, what is the wrong thing that I did? Okay, I am deriving I. So di by dt is equal to E divided by L. So I is equal to 1 by L into integral of E dt. Alright, now you know what is E. What is E that you are going to substitute here?
EM
E is the input voltage.
L into
EM
di.
sin omega t.
E should be substituted as EM sin omega t. So you do the substitution here in place of E. Then what will happen to the equation? I will be becoming equal to 1 by L EM sin omega t. Okay, t. Alright. So EM is a constant, so we can take it out. So EM divided by L, again integral of sin omega dt into
minus
dt.
cos omega t.
Okay. Alright. So now I will be equivalent to EM. If you are doing the integration of sin omega t, what will be the answer that you will be getting?
Minus cos omega t.
L fact.
Omega
Yes, minus omega. Omega is also there. No, we are differentiating this with respect
Minus
to
omega into cos
t
omega.
only. Minus omega into cos omega t. That is after integration of the term. Okay. Alright. Anywhere, sorry. What will be the answer if you are integrating sin omega t? Omega cos omega t or cos omega t divided by omega?
Divided by omega, ma'am.
Divided by
Divided by.
omega. Okay, that is what they would have done here. Okay. Alright, this equation we have got here. Alright, cos omega t Em divided by omega L. Now this whole thing they are denoting it as Im. Now this cos omega t they are going to write it as sin omega t minus 90. Okay, that way it will be equivalent to minus cos omega t. Yesterday you were telling that there is no trigonometric formula that is equivalent to minus cos omega t. You are wrong. Okay, sin omega t minus 90 is equal to minus cos t omega t. Based upon that concept only, they are doing what here? Again I am writing. Okay, this was the equation that you got by this integration. Okay, now minus cos omega t is there. That minus cos omega t is equal to sin omega t minus pi by 2. Okay, always sin omega t minus pi by 2 is equal to minus cos omega t. Okay, that is how this equation comes around here, and you are grouping Em divided omega L as Im. Okay, so the final equation for Im will be obtained like this. So you already know what is the equation for V. What is the equation for V?
EM sin omega t.
Em sin omega t. Now I want to draw the phasor diagram. So how can I do it?
Ma'am, if we'll keep V at origin, so I will be
This is my
outfaced by
I.
90 degree.
Okay. Yes, this is my I, and E is equal to Em sin omega t is my voltage. I want to draw the phasor diagram for these two. So if I want to do that, again I am taking E as the reference. Okay, now I want to draw the current. Now you have to check out the angle. The angle here is 0. Alright, but what about the angle here?
Minus 90. 90, ma'am.
Minus
90
90 degree. So if I want to draw the current will be drawn like this. Okay, the angular difference that I am having is 90 degree. So this is ideal pure resistive circuit, but in practical cases the angle will not be exactly 90 degree, it will be some phi value. So if you see to this diagram is called as my phasor diagram for the purely inductive circuit, where I is lagging behind E or I is leading.
Lagging, ma'am.
Lagging.
Lagging, man.
I is lagging.
I is lagging behind E by how much angle?
90.
Pi
90
by 2.
degree.
90 degree. Okay, so 90 degree, if you have been asked what is the power factor for a purely inductive circuit, then what is the power factor? What is cos 90? What is the angular difference between E and I?
0, ma'am.
0.
0.
This is phi. Okay, this is phi. So cosine of phi is my power factor. So cos of 90 degree is how much?
0.
0. So always when it comes to purely resistive circuit, you should tell that 0 power factor, lag or lead?
Lag.
Lag. Okay, so 0 power factor, lag. Like that you have to tell. Okay, so this is all for a purely what circuit?
Inductive.
Inductive circuit. The same thing you have to do for a purely, what is left out now?
Capacitive circuit.
Capacitive circuit. So that we'll do now. Now, here comes a circuit where you are having what all components?
AC source, current and capacitor.
AC source. AC source is again denoted by what equation? Em sin omega t. Now again I am assuming current that I have to derive. Again by using current voltage relationship for capacitance that I will do. So what is my I here? L into di by dt is equal to V. Now what is my I here? C dV by dt. Is it not? CV dV by dt. That is the relationship for voltage and current for a capacitive element. Now V is the term that I know, that is equivalent to Em sin omega t. So if I differentiate that voltage, what will be the I that I will be getting? Let me do that. Now just I is equal to C d divided by dt Em sin omega t. So tell me what will be the answer. I is equal to C into, if I differentiate, Em is a constant that I can take it out. If I differentiate omega t, sin omega t, then what will be the answer? D by dt of sin omega t, what is the answer? Integration of sin omega t is equal to minus cos omega t divided by omega.
By omega.
D by dt of sin, that is omega into cos omega t.
Omega t.
Okay, omega into cos omega t. Now this omega c I can group together. Okay. So Em I can take it out. So here comes the equation. This is actually Em, not Vc. Okay, so Em cos omega t that I have got. Now I want to replace the term cos omega t by sin. Okay, again by using trigonometric formula. What can I write? This is here omega c Em cos omega t that you have got after differentiation. Now we want to write cos omega t in terms of sin. Okay, so you know the
Sin
trigonometric
pi by
formula, na?
Sin pi
Sin
by 2
theta
plus
plus
omega
90.
t.
Okay, sin omega t plus 90 is equal to cos omega t, so I can replace that term.
Yes, ma'am.
Okay, so what will happen to I finally? This
I
is again
equal-
not Vc, Em. Okay, so this Em omega c they are grouping together as what?
Em, Im, ma'am.
Im. Okay, and Em, you know that omega c, if in the denominator, that will be equivalent to what term? 1 by omega c is equal to what term?
Xc.
Xc.
XC, ma'am.
Okay, so Xc is equal to 1 by omega c here. So if this is the term, if you are substituting, that omega c will come in the numerator, so there won't be any change in the original equation. Alright, so this is your capacitive reactance, omega c. Now again I want to draw the phasor diagram. Now let me clear the page a little bit. Now I know that V is equal to Em sin omega t and I is equal to Im sin omega t plus
Omega t
90.
plus
So
90.
again I want to draw the phasor diagram for this purely capacitive circuit. So how can I do the phasor diagram representation? Again I am taking V as a reference. So I am drawing V. Now I want to represent the current. So how
Current
can I
leads by
represent the
90
current?
degree.
Current
Current
will be drawn like this. Okay, and the angular difference between this V and I is equal to what? What is the
90
angle
degree.
here? 90
95
degree.
by 2.
So this is my phasor diagram for what type of circuit?
Pure conducting.
Purely capacitive circuit. Now how can I relate V and I? I is lagging behind voltage or it is leading the voltage?
Leading. I is
Leading the
leading by voltage.
I is leading the voltage. Again, if I want to determine what is the power factor, what is the cosine of the phase angle between V and I?
0, ma'am.
Zero.
0, ma'am.
Zero.
Cos pi
So
by
the
0.
power factor will be 0 power factor, lag or lead?
Lead, ma'am.
Lead, ma'am.
Lead. So this might be asked in MCQs. What is the power factor's nature for a resistive circuit, capacitive circuit, inductive circuit? So what can you tell?
In resistive circuit, power factor equal to unity, ma'am.
Hmm.
In inductance circuit, lags by voltage, power factor equal to 0, ma'am.
0 power factor, lag you have to tell. Then capacitive circuit.
Lead power factor 0 degree, ma'am. 0.
Okay. So one more thing you have to remember, if it is resistive circuit means V and I will be in phase. If it is inductive or capacitive circuit means V and I will be out of phase by 90 degree. I will be lagging voltage in inductive and I will be leading voltage in capacitive circuit. Okay, that's all. Okay, so we have discussed three types of circuits. What are the three types of circuits that we have discussed? Purely resistive
Purely,
circuit, purely
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 capacitive
inductive,
inductive,
circuit,
Inductive
purely
purely
inductive.
capacitive,
inductive circuit.
capacitive.
Okay, now we have to discuss what will happen if you are combining RL in series, RC in series, and RLC in series. Okay, alright. Before going to that, let me discuss one more triangle. Yesterday we have discussed one triangle. No, what is the name of the triangle?
Power
Power
triangle, ma'am.
One
triangle.
Power
triangle
Power
we
triangle.
have discussed.
triangle.
Triangle.
Power
Similarly,
triangle.
yes, similarly another triangle is also there. That is called as what triangle?
Reactance.
Reactance triangle. So always resistance will be drawn vertically because the real part. Then the reactive component will be drawn perpendicular. So this is my reactive component. So I am drawing it perpendicular. XL is my inductive reactance given by the formula omega L. And XC is 1 by omega C. That is my capacitive reactance. Alright. So I am drawing it perpendicular. Then if we take the vector sum of these two, that will be equivalent to Z. So what does Z represent? R is resistance, X is reactance, Z is
Impedance.
impedance. Okay, Z is impedance. Alright. 1 by Z is called as admittance. Okay, understood all these factors. 1 by Z reciprocal of impedance is admittance, Z is impedance, X is reactance, R is resistance. So this is called as what triangle? What is the name of the triangle?
Reactance triangle, ma'am.
This is
impedance.
called as reactance triangle or impedance triangle, anything. Okay, this is called as reactance triangle. Sometimes they will ask you to draw this diagram in 4 marks. Okay, so you need to know how to draw it. Sometimes this will be asked in pre-lab, post-lab also. So this is how a reactance triangle should be drawn. Okay, resistance should be taken here. Reactance in perpendicular manner. If you take the vector sum, it will be impedance. Now, Z is given by what formula? Square root of R square plus XL minus XC the whole square. Now, what is the power factor by observing this reactance triangle? Here comes another formula for power factor. You know
R
power
by Z,
factor
ma'am.
is equal to cos phi. Cos phi
R,
is given by formula adjacent
R by
divided by
Z.
hypotenuse. Okay, so
R
what is
by
my
Z.
adjacent and what is my hypotenuse?
R by
R
Z.
is
Adjacent is
adjacent.
R
Reactance.
and hypotenuse is
Z
impedance.
Impedance.
So another formula is also there for power factor. So what are the different formulas that you are having for power factor?
Power factor equal to R by Z. Or cos
R
phi.
by Z. Then what are the other formulas? Yesterday I have given one more formula based upon power triangle now.
Yes, ma'am.
What is formula? Real power divided by
Apparent
Apparent
power.
power.
Apparent
apparent
power.
power. That is another formula. Okay, so different formulas are available for power factor. Okay, yeah. Next. So this is what is the name of the triangle?
Reactance triangle.
Reactance triangle. Okay, next we will discuss series RL. The rest in class you understood the concept? Even though you are not answering and keeping silent, I want to know. Want some answer from your side? I'm hoping you all understood. Or do you want me to call out your names? Okay, these things we have just learned. Okay, what will happen if the circuit is purely resistive? What will happen if the circuit is purely inductive? What will happen if the circuit is purely capacitive? And how the current and voltage are related, and how to draw the phasor diagram. All these things are again shown here. Okay. Now let us move on to see what will happen if you are having a series. What circuit is this?
RL circuit, ma'am.
RL.
RL circuit. So for this RL circuit also you have to do some derivation. You have to draw the phasor diagram. Based upon this problems will come. Okay. Now again you are giving what type of supply to this? What is the nature of the supply that you are giving?
AC voltage. AC, ma'am. AC.
AC. Okay, single phase AC. V is equal to Vm sin omega t you are giving. Okay. Now I want to write a KVL equation. Since all are connected in series, the same current will flow through L and R. So observing that rule, if I want to write the KVL equation, then what will be the KVL equation? V will be equivalent to voltage across resistance plus voltage across the inductance. Okay. Now what will be the voltage across the resistance, and how can I write the voltage across the inductance? That is the question. See, this formula you make a note because problems will come from this part. What is the formula for the voltage across the resistance by using Ohm's law?
IR plus L into di by dt.
IR. IR is the formula for the voltage across the resistor. Now in the same fashion, if I want to represent the voltage across the inductor, then what will be the formula?
L into di by dt.
VL equal to I in
No, that is all okay, but here only Excel, all those things you already derived. So no need to go into the origin. Okay. Final relationship, what is voltage across the inductance? If you know the inductive reactance, you can easily find out VL. What is the formula?
I into omega L.
I into XL or I into omega L, whichever may be the case. So this formula you have to remember. Okay, what is VR? IR. What is VL?
I into XL.
Okay. Then you know the formula for XL, that is omega L. You know what is omega, that is 2 pi FL. Okay. So this way you will be asked to solve problems. XL represents your inductive reactance. Now comes how to determine the total voltage. Total voltage is the phasor sum of VR and VL. So this will be representing. This is my. So what is the equation for my total voltage? There is a vector sum that is given now. Square root of what is the equation for total voltage? Square root of
R square plus XL square.
VR square plus VR
VR squared plus VL squared the square root. Now how can I write VR and how can I write VL?
Ma'am, VR
I have
is
to do some
IR1.
simplification. No, I R1 and all. R is the notation. Okay, so I into R, okay, the whole squared plus I into XL the whole squared, square root, that is equivalent to I into Z. Okay, alright. So what is the common parameter? Now I can take that out, no? I squared I can take it out and cut out with the square root. So inside the bracket I will be having R squared plus XL squared. In this side IZ. So I will get cancelled. So this becomes my formula for what? Z represents what?
Impedance.
impedance.
Impedance formula. Okay, so this formula you have to remember. So what are the formulas that you are supposed to remember? Whenever it comes to series RL circuit, the formula for VR you need to remember, given by IR. Then what is the voltage across the resistance? Sorry, voltage
IR.
across the inductance. Inductance?
I into
I
XL.
into XL.
I into XL. So what is XL?
Omega L.
Omega L.
Omega L. What is omega?
2
2
pi
pi
F.
F.
2F. 2 pi F. What is the formula for impedance?
root of
Under
r
root r
square
square
plus
plus x square.
xl
plus
square.
XL square.
Okay, some more formula for power factor they have given. That also you have to remember. Okay, R by Z is enough. If they will give you R or Z, you have to find, and if you take the ratio, you will be able to find out power factor. Okay, now comes how to draw the phasor diagram. So we are discussing about what circuit now?
Yes, ma'am.
We are discussing about what nature of circuit now?
Series
RL.
LR circuit.
Series RL circuit.
Series RL circuit. So now if I want to draw the phasor diagram, I have taken the parameter here as the reference, that is my I and VR. Both are in phase or out of phase?
Out of phase.
Out of phase. Resistive element. VR is the voltage across the resistance.
Ma'am,
Okay,
in
current
phase.
flowing through, both are
In
in
phase,
phase.
ma'am.
So in phase, VR and I are in phase. So I draw the reference. Okay, next I have to represent the voltage across the inductor. Okay, so you know that current lags behind the voltage by how much angle?
90
90
degree.
degrees.
90 degree. So this is my current. So this will be lagging behind voltage by how much angle? 90
90
degrees. So
degree.
here I have to draw what voltage? Here I have to draw VL. Okay. Now if I want to obtain the total voltage, okay, I have to take the phasor sum of VR and VL. Alright, if I want to do the same thing, this is my VR, this is my VL, so this is my total what voltage? V is the total voltage. Okay, this diagram is called as what diagram? Phasor diagram. For what circuit? Series
Series LR circuit.
RL circuit. You have understood how this diagram is drawn and all the phasors are being represented?
Yes.
What about the rest in class? All understood, huh?
Yes, ma'am.
Ma'am.
Yes, ma'am.
Only 3 or 4 yeses I am hearing. What about the rest in class?
Yes, ma'am.
Yes, ma'am.
So let us move on to series RC circuit.
Yes, ma'am.
So this is my series RC circuit. Same way, instead of an inductor, now I am having a capacitor. All the other things are remaining the same. So again, what will be your VR, what will be your VC, what will be your total voltage, what will be your XC, and what will be your impedance in this case?
Yes, ma'am. Would you please
Come on,
repeat?
again, series combination, I is common to all the elements. Input voltage is Vin is equal to Vm into sin omega t. Okay, now what will be my VR, what will be my VC, what will be my total voltage, what will be my Z? This is my question.
Ma'am, VR will be I into R. VC will be I
VR
into
is equal to
XC.
I into R, V is equal to I into XC. What is XC? XC is equal to 1 by omega C, 1 by 2 pi FC. And if I want to represent the total voltage, that is again equivalent to VR squared plus VC squared. Okay, again if I am substituting VR is equal to IR, VC is equal to IXC, I will be able to get impedance formula. What is the formula for impedance?
Under root R
Z
square plus
equal to
X.
root of
R squared plus XC squared. Okay. Now, again if I want to draw the phasor diagram in this case, okay, again I have taken what as a reference. This is my reference. VR and I are in phase or out of phase?
In phase.
In phase. Now I want to draw the phasor for VC. Okay, so this here comes my current. How can I draw VC? I leads VC or I lags VC?
I lags VC, ma'am.
I lags VC, yeah?
I leads VC.
Leads VC by 90
I
degree.
leads
ma'am,
VC.
leads.
So leading. So here is my current. So VC is lagging. By how much angle?
90 degree, ma'am.
90 degree. Okay. Now I want to take the phasor sum. I want to represent total voltage V. So how can I do it? Again, this is my VR. This is my VL. I am taking the phasor sum. So this will be my total voltage. Okay. So this is how you will be drawing phasor diagram for what type of circuit?
Series RC circuit.
RC circuit. Understood how? You have got the phasor diagram?
Yes, ma'am.
See, these formula you have to remember. Okay, if you remember the formula, the problem surely will come from this part. That way you will be able to solve the circuit easily. Now comes your series RLC circuit. That's a final circuit. So if you refer to the circuit, what are the various components represent?
AC source, current, inductor, resistance, and capacitor.
All are connected in. This is my Vm sin
Series.
omega t, that is connected across inductive component, a resistive component, a capacitive component, the voltage across VL, VR, VC you need to obtain, and the current is common, same current flows through all the components. So you need to determine what is VL, VR, VC, Z you need to determine what is the total voltage, you have to draw the phasor diagram. All these things you have to do it again. So you have to tell me what will be the formula. Tell me what will be the
Yes, ma'am.
formula for VR, VC, VL. What is the formula?
Ma'am, for VR it will be I into R. Then VC
As
I
usual,
into
VR is equal to I
XC.
into R, VL is equal to I into XL, VC is equal to I into
I into
XC,
XC.
where XL is equal to omega L,
L.
XC is equal to 1 by omega C, omega is equal to 2 pi F. All these things are same. Okay. Now, total voltage if I want to write, here not only R is present individually with L, okay, there is another capacitance also, all are connected in series. So there might be a chance where capacitance may be dominant or inductance may be dominant. Depending upon that, the phasor diagram representation also will vary, and this equation will also vary. XL minus XC you will get, or XC minus XL you will get, depending upon here. If inductance is dominant, then XL minus XC you will get. If capacitance is dominant, means XC minus XL you will get. Okay. Understood this part? Okay. Here
Yes, ma'am.
inductive part is dominant. Here capacitive part is dominant. So accordingly there will be some difference in the phasor diagram and the behavior as well. Alright. So that you need to remember. They were given here some factors. When what will happen if XL is dominant, the phase angle is positive, the circuit will be behaving like RL series circuit, current will be lagging behind the applied voltage and the power factor is lagging. Suppose if XL is less than XC, that is if XC is dominant, then the phase angle is negative, the circuit will be dominantly RC and the current will be leading the voltage by 90 degree. Okay, suppose if XL is equal to XC, that the circuit will behave like a purely resistive circuit, then that means that circuit will be called as a series RLC resonance circuit. Okay, resonance circuit and power factor is unity. Alright, there are three cases in which the circuit may behave that you need to know. Next comes how to draw the phasor diagram. As I have told you, two cases you have to consider here. One when XL is greater than XC, and the next case XC is greater than XL. So the first diagram is for what case?
XL greater than
than
XC.
XL greater than XC. That is, the circuit is more predominantly inductive. Suppose if you consider second case, means XC is greater than XL. That is, the circuit is more capacitive. But other things are same. Again, you have taken what as reference?
resistance.
Voltage across resistance in phase with the current, that is the reference. Now I want to draw the phasors for VL, VC, then total voltage I have to determine. Okay, I am saying the circuit is predominantly inductive. So this is my current. So capacitance, sorry, inductive component will be leading the current by 90 degree. Like that you have to draw. And current is leading the capacitive voltage by 90 degree. Okay. Then the difference between this VL and VC is also represented, and that will be taken as a phasor sum with this VAR, and the total voltage will be V. Understood this phasor diagram representation? Rather than memorizing, you understand the relationships. That way the phasor diagrams you can draw it easily. Understood why VL is top, VC is down,
Yes, ma'am. Got it.
Yes, ma'am.
why VL is on the top.
Hmm.
VL is on the top means I is lagging behind
Lagging by
voltage
90
by 90
degree.
degree. Why VC is drawn down means I is leading
Voltage by
capacitance
90
by
degree.
90 degree. That's why they have drawn it. And L is predominant. That's why VL is drawn a little bit larger when compared to VC. Okay, and the difference in voltage is VL minus VC. That will be summed up with VR. That will be giving you total voltage. Same way, you have to know how to draw the phasor diagram when the circuit is more predominantly capacitive. Okay, again same concept only. This is my VR in phase with I. VL is drawn up and it is I is drawn lagging behind the voltage by 90 degree, and VC is drawn down so that I is leading the voltage by 90 degree, and VC is predominant, so you have drawn a larger magnitude in this case when compared to VL, and the difference here is VC minus VL and not VL minus VC, and you are taking the phasor sum, that will be the total voltage. Understood?
Yes, ma'am.
Okay. So we are done with all the circuits. Now I have told you how to draw the phasor diagram. Suppose if you want to draw in waveform representation for pure R, waveform, how can I represent? Voltage and current I have to represent. So voltage, let it be sinusoidal, that is equivalent to Vm sin omega t, let this be omega t. How can I draw the current?
Ma'am, same. I am sin omega
Same.
t.
Okay, so it will be varying in magnitude, but other than that it will be okay. So this is my current, that is equivalent to Im sin omega t. Both are in phase. Okay, this is for pure R. Suppose if you want to draw the same thing for pure L, then what will happen?
The current will
Pure
lag
L.
by 90 degree.
Again, Vm is equal to, this is voltage. What about the current?
Ma'am, it will start from down. That is lag
Current
by
is
90 degree.
lagging behind voltage. Okay, current is lagging behind voltage. So if it is the case, means how will you draw?
Ma'am, it will lag by 90 degree.
Okay, like this
Ma'am,
you
at
will draw.
pi by 2 it will be 0.
Yeah, 0 only. This is pi by 2, no?
Yes, ma'am, it
Like
is
this.
right.
Okay, right? So this is my current Im sin omega t. So this phase difference is pi by 2. That is 90 degree lag. Okay, understood? Okay, yeah. Now same way, capacitance also you should learn how to draw. Okay, this might also be asked in 2 mark question. Except phasor, you should know how to denote it in waveform representation also. If it is capacitance means the role play will change. This will be come here, this will come here, that's all. Okay. So let's solve two, three simple problems we'll try to solve. Okay, that way you will be able to understand it better. All are having calculators, no? Wait, it takes a long time to load. Wait. We'll have to solve some star delta problem. Plus I'll do. Okay. So what is being given in the problem? That circuit is a purely resistive circuit or a pure capacitive circuit or a pure inductive circuit by reading the statement of the problem. What are the given data? What ma? What is given in the problem? Shall I pick anybody to give an answer for me?
I'm purely resistive.
Yes, purely resistive is correct. Okay, other than that, what are the other things that are given in the problem? This is a purely resistive circuit only. So what are the other things that are given in the problem? There is a voltage equation that is given.
Value of R.
Okay, and resistance value is also given. Resistance is 25 ohm they have given. Okay, what is being asked to find?
Steady state
They
current.
asked you to find
Steady state current.
current. I is asked. So how will you proceed?
I'm by Ohm's law.
Ohm's law, how will you do? There is a big complicated expression for voltage that is given. V is equal to IR. Yes, it is correct only. But first you have to process the voltage equation. What are the things that are given in the voltage expression? You know how to generally represent any voltage expression if it is a sinusoidal quantity. So how can you represent any
Vm sin
sinusoidal
omega
quantity?
t.
It will
Vm
be
sin
Vm
omega t.
sin omega t minus phi r plus phi. Okay. So you compare this with this equation. So what is your Vm?
Vm is
What is your Vm?
80
What is
root
your
2.
omega? What is your
80
phi?
root 2, man.
Plus 80
Ma'am,
root 2 is
omega
my
is
Vm.
100.
I want VRMS. Always I have to process. Omega t is, says omega is 100. First tell me Vm is equal to 80 square root of 2. It is a sinusoidal quantity. I want RMS value for it. Yesterday we have derived to know what is RMS value for a full sinusoidal quantity. So what is the value?
Vm by root
Remember
2.
the formula.
Vm by 2.
Vm by root 2. So what will be the formula?
80.
80. Always remember we have to use up
80 root 2 by 2.
RMS values only for calculation. Okay, RMS value only should be used for calculation. So if it is Vm, you cannot use. What is your omega?
100.
Omega is equal to 100. Okay, all right. Omega is equal to 100. This one is omega, so omega is equal to 100. What is my phi? Phase angle, lag or lead?
Lag, ma'am.
Phi.
Lag, ma'am.
Lag.
Because it is minus, phase angle is
Minus.
minus 55. Okay, so those data I have to process first. Then only you can use up current. So already we have discussed for a pure resistance circuit, I is given by what formula? Im sin omega t plus phi. Same way you have
Plus
to
pi. Yes, ma'am.
denote. Okay, both will be in phase. So that's why omega t plus phi. Now how can I write Im?
V by R.
I is
Vm by R.
V by
equal
R.
to V by R. RMS, this is my RMS value that I have determined. So
RMS.
RMS is 80 and our resistance value they have given 25 and the
25.
angle is minus 55. So what is the answer for I? 80 divided by 25 is 3.2. Again this is my IRMS. Okay, but I want VIM. So what can I do?
Into root 2.
I have to multiply VRMS into square root of 2. So what is the answer that you are getting?
4.48.
This is my IM. Cos omega t minus 55 is the angle. So IM is, suppose if you are multiplying 3.2 into square root of 2, this is my VRMS into 2. That will be giving you VM. That I have to substitute in place here. That is not V, that is I. Okay, so what is value you are getting? 4 point?
4.512.
3.2 into square root of 2 is 4 point something. 5 and 2. So cos 100t minus 55. Same angle you will have. Okay, so this is one simple problem. Purely resistive circuit. Understood the problem? Solution?
Ma'am, but what
Yes,
is
ma'am.
that
You people understood or
sign?
not?
Yes,
Shall we
ma'am.
proceed to the next problem?
Ma'am, what is that sign
Yes,
in
ma'am.
front of 80?
What sign?
Ma'am, they're in front
Which
of
sign?
80. Here V is equal to 80. Then what is that sign?
Sign you are telling what?
Ma'am, in solution it is given na. Here V is equal to 80.
Angle. That is angle, no?
For what angle?
This one you are asking me.
Yes, ma'am.
Clear, huh? That one you are talking. This is one. That is general angle representation. Okay, this is magnitude. This is angle. You have not studied this in maths.
Ma'am, studied, but here it is angle of what?
Don't confuse about that. Is symbol for angle. Symbol for angle.
Yes, ma'am.
55 is the face angle, no?
Yes, ma'am.
Symbol. So whatever may be the angle, they will denote it within that representation. That's all.
Okay, ma'am.
This is how you will represent angle. Magnitude means you will
Wow.
represent it inside a modulus. This will be magnitude,
ma'am.
like that. R into theta, na. R is the magnitude. Theta is this one.
Okay, ma'am.
That is symbol. Okay?
Yes, ma'am.
Angle, symbol. Nothing special about it. This is angle representation. Now comes what circuit and how you have to solve and what is being asked.
LR circuit.
Yellow circuit. Where is R here?
Pure inductive circuit.
Circuit, ma'am. Pure inductive circuit.
Yes, pure inductive circuit. What is the value of the inductor? L is equal to 0.1 Henry they have given,
1
and there is an
Henry.
expression for voltage. V is equal to again Vm sin omega t plus phi. That you have to compare here. Then determine what is Vm. What is Vm?
20 root 2.
What is Vm?
20 root 2.
20 into square root of 2. So what is I have to convert that into VRMS. 20 square root of 2 divided by 2. So
VRMS
2
is
2 will
20.
get
That
cancelled.
is Vm by root 2.
So VRMS you have determined that is 20. What is omega?
Ma'am, IM equal to 4 root 2, ma'am. 4 root 2. IM value, ma'am. IM equal to 4 root 2.
Okay. Yes. What is 4 root 2? 5.6569.
IM value, ma'am. Yes, ma'am. Yes, ma'am.
Correct only. 5.659. Correct only. Okay. Alright. Now you understood this part. I always tell when I am in the middle of the step, if you are telling the final answer, then what the others will understand? We are done. Okay.
Yes, ma'am.
Now I have determined
Yes, ma'am.
VRMS. Next I need to determine what is current. Current is given by what formula?
IM equal to EM by omega L.
Yes, V by Z, but you don't know Z. Z is
P by Z.
XL. Okay, because this is an inductive circuit. Inductive reactance you have to determine. So what is XL?
Omega L. Omega into L.
As omega L, generally you will indicate one J parameter because it's a complex impedance parameter. Impedance generally will be representing as R plus X, okay, XL or XC, alright. So R plus J XL you will indicate, R plus J omega L they will indicate. So this is my inductive part, alright. That is how they got J omega L. And you know what is omega? What is omega?
50.
What is omega? This is
50,
my
ma'am.
omega t. What is omega?
50.
50.
50.
So 50. L is given, so you substitute everything and you find out, yes. Okay, and one more thing you need to know, okay, there is a J parameter that is given, no, here. J parameter. Yes, for 1J, the angle will be 90 degree. Okay. Minus J means minus 90 degree, like a standard. Okay. So here how much J is given? Positive J. So what will be the angle?
Greater than 90, ma'am.
Plus 90 degree.
J parameter is there means angle is 90 degree. Minus J means minus 90 degree.
Minus
Okay. So the angle representation is 90 degree for the impedance. Now you have used the Ohm's law for finding current. So the magnitude part is 20. The magnitude part is 25. Okay, for voltage and Z. The angular part is how much angle is given here?
Minus 25 degree.
So here for the voltage, they given minus 25 minus 90. Why they have got this minus 90? Tell me.
Ma'am, because
90 degree.
Because the current,
Legs.
ma'am, but current lags, na. So here,
because the current lags behind the
90
voltage by
degree.
90 degree. Okay, because of that only they have summed up, I think so. But it's not usually the case. But here they have did
Ma'am,
it
but
anyway.
here should be plus, na. Plus 90 degree.
What is 205 minus 360? What is the answer?
155, ma'am.
360,
55, ma'am.
205. What is the answer that you're getting?
Hello, ma'am.
Usually they don't do. That only should be there. What, ma?
Ma'am, because in pure inductive circuit, voltage is, ma'am, in inductive circuit, voltage is in front by 90 degree, na. So here it should be plus 90.
Usually they don't use. Okay, I will check out why they have used. Okay, and I will tell you. Okay. Here we are considering only V. I don't know why they have subtracted. Maybe because it is taken as a reference. No, that's why they have added up. I think this is total voltage is there. Assuming maybe. This is VL and this is V, but it will not be like that. Okay, anyway, I'll check up and tell why they have added that minus 90 degree. It should be not the case usually. Okay, I will check it and tell you next class. I have some doubts in this problem. So then we will solve the problem. Okay.
Thank you, ma'am.
Now we all can discuss
Thank you, ma'am.
Thank you, ma'am.
this problem. I'll check and tell.
Thank you.
See here they have not added. I think there is a mistake they did.
Thank you, ma'am.
Okay, ma'am. Okay, ma'am. All understood from your side. One final yes from your side.
Yes, ma'am.
Yes,
Thank you, ma'am.
What about the rest in class? Akhil, Srish, Aryan, Roshan, Ayush, Vaibhav, Vishesh.
Yes, ma'am.
All understood, huh? Rishi,
Yes,
Satya, Gaurav.
Yes,
We are not just saying yes because there are already people who are saying yes. So there's no point.
But still, I want everybody to respond because I might not know that you people are listening or not listening. No, because you are not responding. I
If
don't
we
know
have
whether
doubts,
you
we are
understood or
asking
not.
your doubts, right? So
Yes.
It's okay,
if we
ma.
have doubts,
Thank
we will ask
you.
you.
Thank you.
Okay, ma.
Thank you, ma'am.
Okay, ma.
Thank you, ma'am.
Ma'am, will you
Okay, ma'am.
please share yesterday class video, ma'am?
Yes, yes. I was busy. Okay, today I will try to do. Okay.
Okay, ma'am.
Ma'am, what was you saying about that
Ma'am,
CT?
and